Good afternoon. Thank you guys for coming out today. A couple of PSAs before we get started. Starting next year, Becky Hyde, fellow product manager. It'll be her turn to manage the DEC Lunge series, so you'll start to see invites coming from her starting in January. And next week will be our last DEC Lunge for the year. Also, be sure to check out XUnit.io if you want to see videos of any of the past presentations. For today, we have DEC Engineer Jason McKee with us to talk about automated unit testing. Woo.
That's entirely unnecessary. So yeah, automated unit testing. We've all heard of testing. This kid loves it. I think you'll love it too. All right. So why is it important? What makes it hard? What makes code hard to test? What makes code easy to test? What type of automated tests are we talking about? You know, we kind of preface it with unit testing, but there's other types of tests that we automate, and so what are they? Why are they important? What components make up automated unit testing? And some more practical, like, what does it really look like to do this? So why is it important? In today's most common way that people, deliver software, you'll kind of see the method we show up top, where there's a ton of manual testing. There's some, what you might hear of as coded UI testing in Visual Studio terms, or Selenium testing. This is where people are actually exercising, a real application and seeing, hey, does this application output what I expect? Do the results look like what I want? That can be hard for a few reasons. One, because it's hard to write UI tests that don't actually integrate into real, exercise the full application, including all its dependent services and things like that. There are ways to do it, but it's not, I'm not going to say it's not easy, it's just not common, let's say. And traditionally today, you do a lot more manual testing than you do unit testing. So we kind of call that the old and busted. The new hotness being, we have just this massive, we kind of invert this triangle, we have a massive amount of unit tests. If you do test-driven development, you have just a ton of unit tests. And then you have roughly the same amount of UI tests. That's kind of the middle of the pyramid. And then because we have such confidence in what we deliver from this most base level, we're less checking things after the fact and just more making sure that we didn't screw up any really big things, because all the little things are tested along the way in these smaller unit tests. Also, these triangles are one of the many services provided by resident deck designer Matt Dobson when you tell him you can't draw a triangle to save your life. So these are officially called triangles because they have 2 lines in the middle. So anyway, so what makes code hard to test? If you just, for myself, I haven't done unit testing very long relative to my career. I've worked at Humana 10.5 years. I tried getting started with unit testing in 2012. Didn't understand all the attributes of it, how to make it work. I ended up writing what amounts to a lot of integration tests. For example, I would write a test that would be like, oh, when I call, enterprise eligibility with this user, I should get back this result. And it would test all the code around when I call the service, when the service return comes back, and any mutation or formatting that I've done to the responses, turning normal amount fields into currency formatted dollar amount fields, things like that. Then what would happen was someone would, we'd do a quarterly data refresh, the user at EES wouldn't exist anymore, their data had changed, and my test would break. So that's pretty brittle, and because that's not actually a unit test, that's an integration test, which, given the way that when you don't own the test data, has some questionable value. So when you're just writing normal code, like most of us do, and then kind of and I would say I did until 3.5 years ago or so, I'm doing a lot of these things. I'm constructing these concrete worker classes by hand, meaning, my if my class that I'm in needs help from some other object that has a different responsibility, I'm just going to be like, all right, give me a new one of those guys, right? Because I need the thing he does, so I'm going to do it up and I'm going to call it. That gets pretty hard to test because then when you write a unit test on the thing that's doing that up, you're not just testing your object that you're writing the test for, you're testing the implementation of what are referred to as your collaborators as well, other objects that you need to accomplish, your task. Constructors with side effects. If your constructor does anything other than assign local fields from the things that gets passed, it's got side effects. It's doing stuff that can create bad state for you. Global state is another one that's pretty well understood to be bad, but it's worth calling out. They make it in C# anyway, which is what a lot of our human stuff is written in. It's exceedingly hard you have to go out of your way, I would say, to write a global variable, but not necessarily to create global state. Singleton objects, those can be hard to test because you have one instance of that object, and if your test is relying on that instance, it's not getting recreated every time the test runs. So you can get test pollution from one run to the other because maybe your first test does something to that object, and then your second test relies on, well, assuming nothing's been done, but something has been done. And so that when your test runners, most test runners will run these tests in random order every time. So you kind of get these spurious failures that you don't really understand, and it can be really frustrating. Static methods are hard to test for the same reason, because you're effectively having to test their implementation every time you use them as well. Deep inheritance is just tough to test. Too many if statements, that's kind of telling you something about your object design. If you have an exceedingly long method, or a method that has a lot of branches in it, what you've really identified is that they're kind of distinct responsibilities that could be satisfied by breaking that class from that method apart into separate things. So kind of on the flip side of that, what makes stuff easy to test? If you've heard of Solid, it's just a basic set of principles for software design. So I just kind of list them out there without really reiterating them. Those are fairly well understood and that's very Googleable, let's say. The biggest one that I would or the two that I would talk about is single responsibility, kind of what I just mentioned. When you see that there's too many if statements, that there are multiple things being handled by this class, and that's kind of subjective, right? You can get really pedantic about it, and you can create classes that are 2 lines of code, and then you start to get into the situation where it's like, well, that's more overhead to manage and tougher to understand. So is it really worth it? Do we actually see reuse potential for this thing? Is this responsibility broad enough to warrant kind of reuse, or is it okay? An example the other day, I was looking at like a 25-line method that had two pretty distinct branches in it, and I'm like, well, this is obviously when this is the case and when this is the case, and so I could make that determination later up and call the right dependency. But it was like, it's 25 lines of code. Is it really going to make anyone's life that much better to split it up? Is the test that I'm having to write to verify that behavior bad? And ultimately it was like, no, it's not worth the overhead that we would create by adding another object. So again, I'm not going to say it's subjective, because it's certainly not, but it's conditional in terms of how far you really want to go. You can, as engineers, we tend to go to the nth degree on things, and you'll drive yourself crazy if you start doing that. The other thing that really facilitates having unit testable code is dependency inversion, kind of the D in Solid. And that's kind of the opposite of what we talked about in the previous slide, where we're not, newing up these concrete worker classes. If we rely on some, dependency inversion system or some injection container to give us our dependencies, and we can kind of declare those in a couple ways. You can, some injection containers support property injection, where you mark a property and say, hey, I should be injected from the container. The more common way that's kind of cross-cutting across any different injection container is constructor injection, where you can put a reference to it in the constructor, and the container looks at your constructor and says, oh, it needs this interface, this interface, this interface. Do I know how to make a copy of that? All right, I'll make a copy of that and give it to you. And we'll get to why that doesn't sound on the surface like it's a big deal. Because at runtime it's not, right? It's functionally no different at runtime when your app's running with users in production if you did constructor injection or new to that backend. It makes no difference in terms of how the app behaves or anything like that. But we'll get to why that's important when we start to see how that plays into making code more testable. Another thing is low cyclematic complexity, which is just a fun way of saying when you run code analysis, it's going to say, hey, how much is your method really do? That's kind of what we talked about. Is your method too long? Does it have too many if statements? And that's kind of derived from like how many possible variations are there and how long is this thing? Code's easy to test if it's test driven. Kind of a dumb thing to say, but it's just generally true. And if it's not, you know, we've run into this multiple times because on all of our projects here we do test driven development. So a lot of times we'll look at a test and go, wow, that test looks terrible. So that's telling us something about our object design. So we have to refactor that code, which causes us to refactor the test, which makes the test easier to comprehend and makes the code easier to comprehend as well. So what types of automated tests are there? One we talk about the most common one is unit testing. It's really kind of the black box test. Verifies it behaves as expected. Does it have the right output? Its collaborators, does it work with them appropriately? Functional, this is a test that says, I'm providing input and observes the output. Typically it's automated UI tests, that's the best way to put it. And then really the one I talked about earlier that I have the least success with because of when you don't own the data, you can't control how systems integrate. So system integration testing, which is effectively what we do in our traditional UAT cycle today. We're like, hey, everyone's QA or UAT instance of their apps are up. They're all talking to one another, and then we manually come in and say, okay, does that look correct, right? And so if we focus more on validating the individual units, and some of that comes from collaborating. If you have services that you depend on, talking to those teams, verifying that you understand when a piece of data looks this way for a certain user, how should I respond? Because you can guess all day long about when you're writing your test and saying, well, if the service gives me this, then I can do this and I know I'm good. But the reality is the service may never give you that. So a lot of times when you're talking about dependent service integrations and writing tests for like, if I get this from a service, what do I do with it? A lot of that kind of has to come from real world examples of, I called this service, I got this response. I understand by talking to these other teams that like, yes, this is the expected output for these types of users, so on and so forth. So to write these tests effectively, even down to the unit level, when it talks about system integration, it really does rely on a level of communication with the teams that are producing these things. Yeah.
How do you manage this system integration automated?
Say that one more time.
How do you manage this data for automated system integration testing?
Yeah, so the question was, how do you manage test data for automated system integration test suite? The answer for me is that I don't, because I tend not to have these true system integrated test suites. I think other teams are better at that because I know that for larger integrated release type items, there's a test data management team where you can request like, hey, we need users of this type, and we need them to exist in this environment. And then kind of, you would have to work with that team. I think that's under Angela. You'd have to work with her team, and from that you can derive a set of users that are acceptable to do this type of testing from. In our model, we don't rely on that as much. We let that be the responsibility of our product manager, or in the case of our engagement right now, our product manager and our embedded tester. So they kind of do that manual testing and find those users for us that they need to have to do that. They don't automate the actual integration testing. That's kind of done as part of story acceptance.
And how about unit testing? Do you keep a set of data sets separately and only for the developer use?
So the question was for unit testing, do we keep a separate set of data, and is that only for developer use? Really, for unit testing, the data, as you'll see when we get to some examples, is held within the test. There's not some separate repository. It's all local to the test itself. So just some quick review of terms here. A mock, that's what you'll see most commonly used when we're writing unit tests. That means we're going to have basically a fake object that imitates the interface of another. A stub is a test-only implementation of an interface, less preferable. That may be like, if you can't, like if you have a collaborator that doesn't have an interface, so you can't create a mock of that interface, well then you may have to subclass that object and create a fake version of it that you can pass to the object in your test. A shim is less common. It provides an alternate implementation at runtime. You can do that if you need to test some things that are core to the .NET framework. Like the one we use it on actually in our projects is HTTP client. So if I need to test that I'm using HTTP client correctly, I have to write a shim for that. And that says, hey, instead of calling the normal method when this gets called, call me instead. But it's just a weird kind of .NET specific thing that I've run across. I haven't used it in any other language. Helpers, kind of well understood. Convenience methods, shared test code. One thing to note is that unit testing is not service virtualization. When we talk about automated integration testing and things like that, service virtualization is something that can help support that. But again, just like we talked about with writing unit tests about service results, you still have to know that your service data that you virtualize is correct. And if you do that via reporting, which is one of the methods that you can use with a CA Lisa, then you're pretty confident that yes, this is correct. Then your really only gap is the data in QA somehow widely different than what's in production. And that can happen, but not. You're more confident at that point. So let's look at what this actually looks like. Any questions before we get into that? Any at all? All right, cool. Let's see if I can make this work. There we go. Something like that. All right, cool. So let's take a look. What I've done here is I've just made a simple sample app. It's just an MVC web app. It doesn't have really anything in it. I deleted the default stuff. I made an index controller. It has a very dumb index method, and index view is as dumb as a controller. It just says index, right? So if I'm going to look at what does it look like to write a test for this? What does it look like to test drive this thing? So if here I have sample app tests, and I come down here and I say, let's make a new class. We're going to call this index controller test. So this is kind of where we talk about the anatomy of the test, right? The test has a few parts. So for this example, we're going to use XUnit, which is just a testing framework, very common in .NET. Microsoft uses it to test ASP.NET if you look at their GitHub page. So up here, we're going to declare an index controller, and we'll call it subject. That's just kind of a practice we have here. I don't know that that's necessarily standard or anything, but for me it helps keep focus when I'm in a test to know that whenever I want to test an object in a test, I always refer to it as subject. So in this test constructor for XUnit, that's kind of the part where when a test starts up, it runs through the constructor. And so that's kind of your test initialization, your test setup. So now here, if I want to say subject is a new index controller, that would be that. Now I'm going to declare a fact, which is a way to tell the runner, kind of the task factory. I'm going to declare a fact, and it doesn't know about that yet. So now what we're going to do is from package manager console, we're going to install XUnit. Oh, cool. That's awesome. Okay, well, let me have it. Let me just. This is a human firewall situation.
This is why we test.
What?
Right there is why we test. Because now it's
Beautiful, thank you.
All you have to do is go out and hit that URL on your browser and come back and it's okay. I don't get it. Thanks you, man. Anyway, so now that we've installed XUnit, while we're already here, kind of installing some packages, we're gonna skip ahead a little bit. Well, it goes on its own. I'll leave that. So now we're gonna write a test that says index shows or gets data from a collaborator. Well, if I could spell collaborator, that would be cool too. All right, so this is saying, all right, here's something I want to test. So now I'm going to call subject index. That's the method under test, and that's going to return. And I'm going to just pull this up side by side so you can take a look. So that's going to return a view. So that's going to be an action result, or we can just go ahead and make that a view result. If you're familiar with .NET, that's not going to be weird. So then over here we'll say var results equals that guy. And so we're going to have this collaborator, just as a generic term. It could be enterprise claim service, it could be Atlas, it could be spending accounts, it doesn't matter. So you'll notice if you're being observing, you notice line 17 is a little sad because I've kind of already declared that index controller gets constructor injected. And this is again why this is going to be important. It gets injected in iSimple collaborator. So over here, I'm going to try to make a mock. Uh-oh, we don't have that. So this is where I was going to skip that a minute ago. So this is the package that we use. And again, Microsoft uses this one too in the ASP.NET testing. This is what allows us to create mock outputs. And that is not how we alter. There we go. So we're going to make a mock of an iSimple collaborator. Call it simple collaborator. Again, spelling. And in our test setup, before we new up our controller, we need to new up our simple collaborator. So I've made a new mock of the simple collaborator. Now I'm going to inject it when I call this. And you'll notice at test time, I'm not relying on an injection container because that'd be me testing the dependency injection container, which is already tested. That's a dependency. I assume it's good, right? What we might not be able to, what we might test about the containers that I've set up correctly. And that's the types of things that we would test through a functional test where if I load the app, is it 500 and tell me it can't find a parameter as a constructor because the container hooked up correctly. And I'll show you that in a minute. So now we've got our setup done, or this isn't necessarily our setup, this is kind of our table state. Before any test is run, we've got to set up our subject and all its collaborators and get it running. So now we've got this result, and let's say that we have this simple collaborator, and when you have a mock, you're going to do, and this isn't unique to .NET in terms of how you handle mocks, you've got to set it up somehow. So in this framework, we say, well, I'm going to say it calls a method called getData with some parameter. And now I'm going to let ReSharper kind of create this method for me. Let's say it returns a string, and it takes some parameter, right? And now, I'm going to let ReSharper kind of make me a little happy. I move that to its own class, and then ReSharper now wants to implement the missing members for me. So right now it's throwing a system not implemented exception, and that's perfectly cool because we're not testing simple collaborator implementation yet. We're testing how index controller interacts with simple collaborator. So if we get back to index controller test, and we say that it's going to return my data, right? So why is that important? Because now I'm going to say down here that results dot model as index model, and again, just making these classes up as we go. Alt entering your way to happiness with ReSharper. I'm going to move that up to the appropriate place. And And by appropriate, I just mean out of the test project, right? So now we have this view model. It's going to power our index view, which is super cool and dumb right now. So then what we're going to say is assert equal, and this is kind of where we're getting into the assertion portion of the test. So with testing, you always have an expected and an actual. The expected is what do I want it to have? Actual is what do they get back? Do they match, right? So I'm going to say I expected to see my data, and I expected that to be equal to actual dot collaborator data, which again doesn't exist. So with resharper, we're going to alternate our way to happiness, and for some reason resharper thinks items char is more appropriate than string, which it's not. So now we have this view model with this collaborator data on it, and we're going to assert that it's equal. So now we're going to run this test, and it should fail pretty spectacularly, because as you can see, our implementation over here doesn't really do anything. Well, let me pull it from here. That's kind of neat. That's what you get for doing live, I suppose. Well, I think I know this. Because it's in Visual Studio, we have to install package XUnit.runner.visual studio. Test run test. Let's see if that picks it up. Oh no, there we go. We have some build failures. This home controller thing, we got rid of him. We decided that wasn't good. Alright. I wondered what it was whining about. So hopefully this runs now. There we go. Great. Null reference exception, object not sent to an instance of an object. Where's that happening? It's happening on line 35 because the model, there's no model being returned. So that's a fair failure. So now we can actually move into implementing this guy. So now we might say, all right, this is why it's important, because the mock object that I've created is getting injected for me via the constructor. So now I can just simply reach out and grab and say, so our data equals simple collaborator, get data, and in this case, I have to pass some parameter. That might be a member ID, it might be some piece of data, but for example's sake, we're just making it match what we set up so that it works. So we're going to return a view, and we're going to make a new index model here, and we're just going to assign the collaborator data equal to data. And now if we rerun that, I believe we should pass. Yeah. So that's kind of an example at the most basic level of how test-driven development works and how writing these type of unit tests works. Again, making these things read-only in a .NET sense is kind of cool because that means they can only be modified in the constructor. So in other words, that's adding a little bit of safety to say, nowhere in my test could I randomly new up subject again and then make some call and create unexpected behavior, right? So this is just a real basic anatomy of a unit test, specifically in .NET. Does anyone have any questions about any of that, or does any of that not make sense? Or is there a specific case that you want to see, like, how do I test this? Like, because there's a lot of different types of tests here, right? Yeah?
I know in demand out there, the squids is a big drive for traceability of the test and documentation. Does this tool provide that document, that audit trail, or that artifact that says this was tested, is it passed?
So the question was about squids, and does unit testing provide any real help in terms of squids and giving us some kind of proof that things are tested. No, because they're really different level of things. When you talk about squids testing, that's what we talked about related to system integration testing and the types of testing that like a product manager or an embedded tester might do. Those are the types of things that you would handle there. So no, unit testing is not about squids. Unit testing is really more about giving you confidence in your ability to deploy software rapidly. If you have built a solid bed of unit tests and that you can verify that when someone makes a code change, you run these tests and yep, all my behavior expectations are so good, then you're confident that that can go to production and cause very little issue, right? You still take it up through an environment, do a manual integration test, make sure things look good, and then you push it on. This presentation is kind of a modified presentation of one that Brandon Edgerton and I gave at DevOps Day a couple weeks ago. But to tie that back into that, this type of stuff really does support continuous delivery models, continuous integration models. This is, you know, we hear DevOps and that means like an array of things. It's kind of this nice corral in which we put these good practices. But really, this is around continuous integration, continuous delivery. And these things, writing tests like this really enable that. So that when it does come time to file a thing in squids, there's so much less that people have to test because there's built-in confidence from the team. You don't have confidence day one, right? I can write you a terrible test that passes, no question. But so over time, you gain that confidence, and that, you know, when you do that manual verification, be it story acceptance or just regression testing, that you feel like you have to do less. Basically. Any other questions before we move on? Yeah.
So one of the big complaints that we get when we say, okay, we need you to unit test, we need you to unit test, it drives quality, is that, okay, well, I've got to write the unit test cases, and it's going to take me longer. And you know, from your experience in that, do you see the time savings that unit test gives you down the road versus I code it real quick, throw out garbage, and then I have to go back and fix it?
Yeah, the question was, do we see time savings related, you know, to the time it takes to write tests and then the pressure to deliver? How do we evidence the value of testing amidst the pressure to deliver? What I would say that if you're doing test-driven development, you're not writing extra code. You're writing the code, you know, in principle, you're not writing extra code, right? In your actual implementation, you're only writing what's necessary, right? Like, I could put a whole bunch of other code in here that does a bunch of stuff, but it's not necessary because the only behavior I care about is that the model has my data in it and it brings collaborator data. So I know that for me personally, a lot of times when you don't know how to write the test, you'll do what's called a spike, and you'll just kind of do what you're talking about. Write something to understand, like, how do I kind of explore the problem space, so to speak, to get a better understanding of how to write that test. And then when I get there and I come back to write that test, what I realize is that, like, a lot of the code I wrote to get to where I thought I understood something is not really necessary, and so I can reduce the amount of code that I've written, which is the best thing to do. Deleting code is a very liberating thing. There's less complexity, there's less to understand. You're doing a favor to everyone who comes behind you. Say, I don't have to look at your thought process that it took you to get from A to B. So in terms of, do we see the time savings? Absolutely. It really is an investment that pays dividends over time. As a code base grows, the fact that you know these tests are solid saves you a lot. From a developer perspective, it frees you from like fear of changing something, because you know if you change something that alters the behavior that was expected, your test is going to tell you, right? And if your stuff is properly segmented and test-driven anyway, you're probably not going to do that because you're only going to be modifying something within the context of an implementation, right? So that's, to dovetail into another point, it's kind of like what we call a green-to-green refactor, right? If the tests are green, I refactor the implementation, tests stay green, cool. I don't need to change the test because the expectation is still the same. How I arrived at that result is immaterial, right? Justin,
Yeah, I think you mentioned testing data, like how do we test data in the test? So it might show us examples. Say your collaborator is a service that returned member status of 1, 2, or 3.
Yeah, sure.
Which is supposed to be translated to active, inactive, or deceased.
Yeah.
How could you do that?
Right. So let me do that. So let's say that now our index model is going to have more to it, and we're just going to kind of ignore single responsibility principle and set simple collaborator up to do some other work for us, even though it's probably not as general. So get other data. And it's going to return a list of, well, let's just say it returns a list of strings. That's fair. So now, and you said talking about new data transformation. Sure. So I'm going to introduce something that's different than a fact. It's called a theory. And a theory says it holds true for all these conditions, right? So if I'm going to say like this, basically this is saying S should get translated to spouse. And let's say like C should get translated to child, right? So then when that happens in XUnit, those become parameters to your test. So here we'll have source value and expected value, or expected transform value, let's say. And I'm going to go back on what I said. I don't want this to return a list. I don't want it to just return a string, because that'll make my test easier for this example. So again, we just leave him not implemented. He just needs to exist to avoid a compiler, right? So this is going to return source value, that parameter that comes in. So now I'm going to say assert equal transform value, which is the second value coming in from the theory. And that's going to be equal to actual dot, I'm just going to say transform dot create. Well, it's hard to alt enter on Mac. There we go. Create that property, and again, it's always sharp that it should actually be a string. So now I'm going to say that that's what we expect, right? So now I'll run that, and we should, and the reason we run it, even though we know it's going to fail, is we want it to be a good failure, right? So now we know it should fail specifically, we know where it should fail, and we want to make sure that's where it's failing before we go implement anything. So we expect it to fail on line 41, right? Because the my data piece of it should still be true. So now it fails on line 41. That's what we call a good failure. So now if we come over here and we simply say, all right, var other data, we'll call it simple collaborator, get other data. And now we're going to have to say something in here like, all right, well, transform value equals, so we'll say if other data equals S, then transform value equals spouse. Source is not word. Else transform value equals child. So under transform value, we run those again, and we should see a pass. So that's an example of how we might test these transformation type things. It was convenient that we could do it with the theory in this case. But again, like I mentioned, I can write you a bad test and pass it, right? So if we're treating this get other data method as a collaborator that we're dealing with, right now we're kind of assuming the data dictionary, what it can return is S and C, right? And frankly, all we've done in the test is make sure that if it's S as spouse, anything else, it becomes child. So in a way, that's kind of weak, because now I could say, if at runtime I passed it like E for employee or S or something else that denoted not a spouse or a child, like P for primary, then it would show child. So at that point, the question we like to ask is, what's insufficient, the test or the implementation? The answer is the test, because the test should be defining the behavior that drives the implementation. So if I want to do that and make that a more sufficient implementation, I can just add an inline data there to the theory, run it, release that. All right, cool. I wondered why it was quiet. I thought I was doing boards out there. Yeah, so now we see E doesn't work. The other two continue to work, but the E one doesn't work. So again, you can kind of take this to the nth degree in terms of what's correct, but so again, well, that was terrible. I should have compiled. So again, you see it leaves us open, but it's just a matter of, you have to know, it's again about the communication. Do you know that's the full list of values? Do you want to do something if you encounter an unknown value? You know, should you show anything? Should you default to anything at all? Those are all different decisions that aren't about writing a test. It's about understanding your collaborators. So yeah, that's just kind of a brief example of how you might do TDD and what the anatomy of a test looks like and how to deal with collaborators and things like that. Anyone have any questions about that? Yeah.
Speaking back to some of the value and immediate feedback that you get from this, I know you can set it up in TFS such that when a coder checks in code, it'll immediately run the test suite and verify everything works perfectly. Generally, it should work correctly, but sometimes coders check in things that do not work. Does TFS have the ability to auto-generate like a TFS bug or a work item and assign it back to that developer?
I believe it does. We don't utilize that, but I believe it does. Just as an example, the project I'm working on now, here is our continuous integration pipeline for the new MyHumana dashboard. So it fires up SonarQube, runs our unit tests, pushes the web app to PCF, runs our functional tests on PCF before it goes into any of our other environments. So yeah, you can absolutely hook those things up. I believe there is a way to do that. Mark Gardner is going to know best on that. That's kind of his deal.
I've been talking to him some, because my immediate thought was back to your question about squids. It's a very manual. You look at the failed test case, you go and create a defect. But for TFS, you could auto-generate, seems to me, auto-generate some type of bug and assign it to that developer.
Yeah.
So that'd be tremendously valuable.
Yeah, the trick is you really just have to be able to, you have to build confidence in that automation too. And so that's going to be a thing that happens over time. And then eventually you're going to come to a system that does do this. Ideally, when somebody checks something in, they're watching the build to see as it goes through. But, you know.
There's some sort of they had to check some balances. The Humana has very strict. You're going to go to production, you have to have this testing. It says you did the test.
Yeah.
It's automated testing. I was wondering if somehow can you create like a test script that was hey, this is like I run how many test scripts.
Yeah, I mean, you definitely can. The types of tests that you would do there would be like functional tests that interact with real services. So, I mean, in theory, you could. Squids would have to provide you some kind of facility to import that stuff, but yeah, you could.
How this test program can be run against the QA in production environment, because generally developers doesn't have the rights to insert, update, delete data in the upper environments. So how the business users can run this?
Sure, so you don't run it against anything but your local. You don't run unit tests against production environments. You only run unit tests on your local machine. The things you would run against actual environments are those functional integration style tests, where it's no different than if you were out there clicking around with the browser, right? The access is the same as if you had credentials and could click around with the browser. Yeah.
What tools have you tried to use for system integration testing?
Sure. So for system integration testing, on this project that I'm working on, the new MyHumana, which you should, if you have Humana insurance, you should be seeing when you log in now. We use Selenium. Yeah, so Selenium is an automated UI test. just show you really briefly, since we have just a little bit of time, what a Selenium test looks like. Basically, you're newing up a browser, like an actual browser that shows up, like pops a browser window on your machine, and you program it to say like, hey, find this item on the page via like a CSS selector, and verify that the test or that the data is there. So in here, so like as an example, we have a base class that handles like newing up the Chrome driver, managing the size of the window, and then we have it automated to do the login. So you see like driver, find element username, find element password, send those keys. So it's like you actually see it type in the browser. And I can run these and just let you see what they look like really quickly. Because it won't hurt while we field another question. Anybody have any more? Yeah, Nick.
My question is actually for Matt. Big fan of triangles. Where do you ever split squares?
So you can see these are the integration tests that are running. These are using fake data, but you notice it does fire up a full Chrome browser every time. Fires up and shuts down pretty quickly. But yeah, these are the types of things where we validate, like, hey, this is on the right part of the page, given this kind of user, so on and so forth. So all that's facilitated. Oh, and then the tough to stop. Oh, it's best to just let them finish. There we